Space is something almost everyone thinks they understand. Sure, it may seem straightforward enough. It's big, it's dark, it's mostly empty, and if you travel far enough in any direction, eventually you'll reach the end of it. We've seen the pictures, we've watched the documentaries, we feel like we get it. And yet, here's the part that should unsettle you. Nobody has ever actually seen the edge of the universe. Not with the most powerful telescope ever built. Not with every satellite we've ever launched. Not even in theory. Because the truth is stranger than that. The universe might not have an edge, and even if it does, the laws of physics themselves are conspiring to make sure you can never, ever reach it. What is actually out there, beyond everything we can see? Why is the universe hiding its own boundary from us? And what does it mean for everything, including you, that some parts of reality are permanently, irreversibly? Well, beyond reach, I'm Richard, and you're watching EW Universe. Today, we're going to the very edge of everything, or at least, we're going to try. Let's start with something deceptively simple. When you look up at the night sky, when you stare into that ocean of stars, what exactly are you seeing? You might think you're seeing space as it is right now, but you're not. You're seeing space as it was. Here's why. Light travels fast, extraordinarily fast, at about 300,000 kilometers per second, but it doesn't travel instantly. That means when you look at a star, the light entering your eye left that star years, decades, and sometimes millions of years ago. And here is where it gets genuinely unsettling. The furthest galaxies we can observe today, the ones at the very limit of what even the James Webb Space Telescope can detect, their light left them nearly 13.8 billion years ago, almost at the very beginning of time itself. We are not looking at the edge of space. We are looking at the edge of time. Think about that for a moment. Every direction you look in the night sky, and you're staring into the deep past. The universe we see is essentially a photograph taken over billions of years, and we are standing right at its center, completely surrounded by ancient history, with no idea what any of it looks like today. That sphere of everything we can possibly see, everything that has had enough time to send light to us since the Big Bang, is called the Observable Universe, and it stretches about 46.5 billion light years in every direction. But here's the question that should stop you cold. What's outside it? To understand why you can never reach the edge, you first need to understand something Edwin Hubble discovered in 1929, and it changed everything. Hubble was studying distant galaxies when he noticed something deeply strange. Every single galaxy he could observe appeared to be moving away from us. Not just a few of them, all of them. And the further away the galaxy was, the faster it was retreating. Imagine you're standing in a crowd of people, and suddenly, everyone around you starts walking away from you. The people closest to you are walking slowly, but the people on the other side of the room, they're practically sprinting away. That's essentially what Hubble was seeing. This discovery led to one of the most profound realizations in the history of science. The universe is expanding. Not the matter within the universe, but space itself. The very fabric of reality is stretching, almost like a rubber sheet being pulled in all directions at once. And here is where your dream of reaching the edge quietly dies. Because if space itself is expanding, then the further away something is, the faster it's moving away from you. There exists a certain distance, a threshold, beyond which galaxies are receding from us faster than the speed of light. Not because they're physically moving that fast, but because the space between us and them is growing so rapidly that the gap is widening faster than light can cross it, which means their light will never reach us. It is already gone, forever. This is what scientists call the cosmic horizon, and it is one of the most haunting concepts in all of physics. Think of it like this. Imagine you're a sailor on an ancient ship somewhere in the middle of the ocean. You can see a certain distance to your horizon, and beyond that, nothing. Not because the ocean ends there, but because the curvature of the Earth means the light from anything further simply cannot reach your eyes. The cosmic horizon works in exactly the same way. Only beyond a certain distance, the universe is expanding so fast that light from those regions could set off toward us right now, at full speed, the fastest thing in existence. And it would still never arrive. The gap would grow faster than the light could close it. And here is the part that should genuinely disturb you. It's not just that we can't see what's beyond the horizon, it's that we can never affect it either. We could send a signal, a probe, some message, anything, in the direction of that horizon, and it would never cross it. Those parts of the universe are not just invisible to us. They are causally disconnected from us. They might as well be in a completely different reality. There are galaxies, possibly billions of them, that existed once within our reach, that are now slipping beyond our cosmic horizon as we speak. Carried away by the relentless expansion of space, gone, permanently, never to be seen or contacted. And again, if you thought that was troubling, brace yourself. Because in 1998, two separate teams of astronomers studying distant supernovae made a discovery that won them the Nobel Prize, and quietly horrified the scientific community. The universe isn't just expanding, it's expanding faster and faster. something which scientists have named dark energy, though they are the first to admit they have almost no idea what it actually is accelerating the expansion of space itself. Like a hand pressing down on the accelerator of the universe, pushing everything further apart with increasing urgency, this means that over time the cosmic horizon is not staying put, it's shrinking. In terms of what we can affect, galaxies that are currently within our reach will one day slip beyond it. Stars we can see today will one day fade, redshift into invisibility, and vanish from our sky entirely. And in the far future, in the unimaginable long stretch of cosmic time ahead, the night sky will go dark. Not because the stars burned out, but because the universe will have expanded so much that every other galaxy will have been carried beyond our horizon. Astronomers who exist billions of years from now, if any exist at all, will look up at the night sky and see almost nothing. They will have no way of knowing the universe was ever as full as it is today. Well, they will look out at an empty cosmos and conclude reasonably that the universe is just the Milky Way, alone in the void. They will be completely, catastrophically wrong, and there will be nothing, no signal, no message, no evidence left behind that we could send them from today to tell them otherwise. Now, here's the part where things become truly strange. We've been talking about the observable universe, the sphere of everything we can see, but that's not the same as the total universe. The total universe, the everything that actually exists, could be far, far larger. In fact, based on our best measurements, it could be infinite. Most scientists have measured the large-scale geometry of space using the afterglow of the Big Bang, a faint radiation called the cosmic microwave background, and found something remarkable. Space appears on the largest scales to be flat, not curved inward like the surface of a sphere, not curved outward like a saddle, flat. And in mathematics, a flat universe has no natural boundary. It could extend forever. But here's the maddening part. We can't know this for certain. Because we can only see within our observable bubble, our 46.5 billion light-year sphere. Anything beyond that horizon is invisible to us, in principle, forever. We are like goldfish in a bowl, trying to reason about the ocean. Some scientists have proposed that the universe might be finite but unbounded, like the surface of a sphere, where you can travel in one direction forever, never hit an edge, but eventually loop back to where you started. Countless others propose there is no outside the universe at all. That asking what's beyond the edge of the universe is like asking what's north of the North Pole. The question itself might not be valid. And then there are those who entertain the possibility that our universe is just one bubble among countless others, a multiverse of separate realities, each with their own laws of physics, born from the same cosmic inflation that created ours, but forever beyond any possible contact. All of these possibilities are consistent with what we know, and none of them can be ruled out. And fundamentally, perhaps the most unsettling part of all of this is what it implies about our place in everything. We didn't used to know any of this. For most of human history, the universe was the sky you could see on a clear night, a few thousand stars, a moon, the sun. Then telescopes came and the stars turned into galaxies, and the galaxies turned into billions of galaxies, and the universe became larger than imagination could comfortably hold. Just now we know that even the breathtaking enormity of 46.5 billion light-years of stars and galaxies, maybe just the tiniest fraction of a larger reality that we are permanently, physically, cosmologically prevented from ever accessing. Think about what that means. There could be stars out there right now, planets, life forms perhaps, staring up at their own night skies, wondering the same questions we are. And we will never know, not because of a lack of technology, but because the universe itself has drawn a curtain, and it keeps pulling it further away. The edge of the universe is not a wall you can stand in front of and press your hand against. It is not a destination you can plan a journey toward. It is a horizon. And like all horizons, it retreats as you approach, forever out of reach, always just beyond the light. The universe is under no obligation to be knowable, and the part that keeps physicists awake at night, we're not even sure we're asking the right questions yet. Check out our related videos on the EW Universe channel, where we dive deep into the strange physics of the universe. Thanks for watching.